In this video, we'll discuss the limits and continuity. Let's start with the limit of a function, then the one-sided limit, then we will have the vertical and horizontal asymptote, then we have to sketch the curve, and we'll discuss the continuity of a function. So, limit of a function. Now, the limit of function is actually finding the function at a certain domain which is not necessarily be equal to that domain. For example, suppose we want to evaluate the function at a value of, let us say, 4. So, we can do it using the limit. So, therefore, if we apply the limit principle, it is not necessary to use the 4 as our input. It is the value that is very close to that number. Okay, so we call that as the limit of a function, which means that the domain that will be used is not necessary that it is that exact value to evaluate the function. We are looking for the nearest number or value of that number. Okay, suppose we have this problem. Evaluate the limit of a function below as x approaches 1. So, this is the function which is 2x squared plus x minus 3 all over x minus 1. So, we are asked to evaluate the function as x approaches 1. So, therefore, it is not, x should not be necessarily be equal to 1. But our concern is, because exactly 1 is actually an infinite number. It is undefined number. So therefore, we are not allowed to use 1 here. Instead, we will use the principle of limits. It is as x approaches 1. So when we say approaches 1, we can substitute this as x is equal to 0.999. So the closer you are in 1 is actually you are evaluating the function as approaches to that number 1. Okay, we can also substitute here 1.0001. Okay, so it is also, we have the left limit and we have the right hand limit. The left hand is point something 0.99 and the right hand is 1 point something 1.001, for example. Okay, so we have two kinds of process evaluating the limit of the function of this function as x approaches 1. So let's have the analysis. What will be the response if we substitute x here? Then that x will be moving towards 1. Okay, now remember that moving towards 1 is, this is the 1 value. Look at the graph. So towards 1 is, there are two kinds of the process. We have from left hand and we have from the right hand. Okay, so the left hand number are number to the left side of 1. So the left side of 1 is negative number 0.5, then very close to 1.99 something. And from right is, it can be used from infinity, positive infinity, going to approaches 1 to 1.5 and so on. Okay, so let's have the what will be the response of this function when we substitute the value of x or evaluate the function as x approaches 1. So what we have here, from left side of 1, from left side of 1 is the left hand limit. Okay, then we have also the table from the right hand. So let us see what will be the response on doing this activity, that we want to know the response of the function as x approaches 1 from left and from the right. Let's start with 0. 0 is from left hand of 1. So what will be the value of the function, because okay, so you have to substitute x here, 0, 0, 0, so the answer is 3. So when x is 0, y is equal to 3. So therefore, this will be the graph. When x is 0, y is 3. Now in the right hand, when x is equal to 2, substitute 2 here in the function, evaluate the function, when x is equal to 2, so therefore, we have here the values, and the answer is 7. So, evaluating the 2 here is 7. So, when x is equal to 2, then the point of relation is, we have the 2 and 7 coordinate. So, from left hand, we have 0, 3, and from right hand, we have 2 and 7. Okay? So, okay, then next, we will move from 0 closer to 1. Let us say 0.25. And the response, after calculation, we have 3.5. So, when x is equal to 0.5 here, then we have this value. So, this is the response of the y value when x is equal to 0.25. Now, when x is equal to number from 2 closer to 1, let's move with 1.75. So, we are now approaching 1. Now, the result, after evaluating the 1.75, using your calculator, we can have the 6.5 number. So, therefore, when x equal to 1.75, we have this result. Okay? So, look at the trend. This is moving, this point is moving, increasing from left, while in the right is decreasing number. So, what point will the function responded at what number? So let's continue. So suppose we have 0.5, then the response is 4. So we have this 4. In the right side, suppose we have 1.5, the middle part, we have 6. So therefore, we have this. So continuously, the left hand is keep on increasing linearly. Okay, and this is also decreasing linearly. So continue 0.75, 4.5. Okay, then at the right 1.25, we have the 5.5. We have this 1.5. Then continue in the left side again, 0.9, very close to 1. And we have 4.8 for the function. So therefore, we have this point. Then in the right side, in a 1.1, very close to 1 from the right side, we come up with 5.2. So therefore, we have this. Okay? So continue, 0.99, 4.98 is the response. Then at the right side, at 1.01, very close to 1, we have 5.02. So take note of the increasing and decreasing response of x. It is smaller and smaller as we approach this 1. So if we extend again this 0.99, let us say 0.999, then the response is 4.998. So remember, this is 4 from 4.8, 4.98, 4.99. This is, and in the right side, okay, in the right side we have 1.001. We increase the number of 0 in order to approach closer than closer to 1, and the response is 5.002. Look at the result. Actually, this is from left is approaches 5, and from right is approaches 5 also. So if we increase again, if we increase the number of it, the response again in the left side approaches very close to 5. In the right side, we have 1.001, the response is 5.002. Okay? So if we increase again and again and again, look at the result. The result is, will move, the point will reaches approximately equal to 5. So even if you increase this one, still this will 4 point, the increasing number is only the 9, and this one is the 0 increasing number digit. Okay, so therefore this is it. So therefore we can say that if you connect these points, actually this is linear. So therefore this function is a linear function. It has a linear relationship. Okay, so we can say to answer this problem, to evaluate the limit of the function as x approaches 1 of this function to x squared plus x minus 3 all over x minus 1 is approximately equal to 5 or is 5, because the word limit means not necessarily be equal to that number. Okay, so look at the graph. From left approaches 5, from right approaches 5. So the limit exists as 5. So the limit of the function 2x squared plus x minus 3 over x minus 1 as x approaches 5 is 1 is 5. Okay? So mathematically, we can do this without this statement. We can use the word lim corresponds for the limit. So if we encounter this kind of mathematical notation, you say that the limit of this function, the function is 2x squared plus x minus 3 over x minus 1. As x approaches, the arrow means approaches 1 is 5 or equal to 5. So therefore, this is the answer. Now remember this, we can use the sign of equality here because we use the word limit. Without the limit, then we cannot use this as equal to 5. So the limit signifies a number approaches to that number. Okay? So the response 5 if we take the x approaches 1. Now, so therefore, if we use a number, let us say epsilon, this number is a this greater than 1 or greater than 0, but a very small change, which means that in the left side we have this value, okay, 5 minus epsilon, and we have the 5 plus epsilon. So e corresponds to a very small number. So meaning if you decrease that number, you can do it by what? By decreasing also the difference from 1 with a certain number. Okay? This is delta. So this value is a very small. When you subtract 1 minus this number, this will come up to a very small. This is greater than 0, but it is a very small number. So that we have also the 1 plus delta. So take note that previously we started with 0 in the left hand, and we have the 2 at the right hand. So if we subtract 1 minus 0, so therefore the result is 1. So therefore, if we increase this as this lambda, because our lambda in the left side in the previous slide is 0, then it should be 1 minus that 0. Then as we go on or moving towards 1, the difference between 1 and this number is keep on decreasing. So as this number reduces to close to 0, then we have this value also, which is the response, the epsilon, which is very close to that number. Okay? So we have for x1, the function of 1, this is a function of 1, then we have this response of the function. As we increase this or reduce this amount, then we are approaching to that value. So this shaded part is the left hand limit, and we have this as the right hand limit of the function. So all of them approaches to 0. So therefore, again, we can say that the limit of the function, which is 2x squared plus x minus 3 all over x minus 1, as x approaches 1 is 5. That is if the epsilon, which is greater than 0, however small, so this must be a small number. Then there exists a delta which is greater than 0 such that 0 or the x absolute number, absolute value of x minus 1, okay, x minus 1, this number is greater than 0 but not more than the delta. Then the absolute function minus 5, this is the function minus 5, it must be less than the epsilon. So therefore, that's it. So again, if we have this value from left very very small, that is 1 minus this delta, then we will approach to a certain number 5. Similarly, from the right, if we have this number that if we add 1 plus this number, it will be approaches to that 1. So therefore, this must be a very very small value, the delta also. Okay, so that's it. So exists, because we have this value, we can say that the limit exists at 5. Okay, so let's have now the formal definition of the limit of a function. Let f be the number, a function defined by every number in some open interval containing a. So a corresponds to a number. This must be a real number itself. So the limit of the function as x approaches this a is L. So it is written as, so therefore we are given this mathematical statement that the limit of the function as x approaches a is a real number, will be equal to a number L. So this should be a real number also. So in our previous, we have the limit of the function, which is the function given as x approaches 1, and the answer is 5. So this must be a real number, and L also a real number. So this is the condition that the epsilon is greater than 0 but small, and there exists the delta which is greater than 0 such that it will fit on this statement that the absolute value of x minus a, which is the number, okay, should be greater than 0 but not more than the delta. Okay, then the absolute function minus L should be less than the epsilon. Okay, so therefore, we'll go back to this problem. Suppose the problem says that evaluate the limit. Actually, we are evaluating. So this one says that you have to evaluate the limit of this function, which is the function we used in our previous slide, as x approaches 1. So therefore, when you substitute it here, actually you are not again substituting 1. But mathematically, how can we do it in order to provide the answer of 5 mathematically without using the table? Okay, the strategy is you have to do something about the function. So in this case, remember, this is a quadratic trinomial. Okay, so if you recall on your algebra that the quadratic trinomial, it has a factor of 2 binomials. Okay, so all you need to do is to factor this one, then find the common, the same factor in the denominator, so that you can reduce this fraction. So in other words, the strategy of evaluating the limit is to look for the function. Then you have to reduce, okay, simplify, or okay, you have to simplify the fraction if it is a fraction or a number. Then analyze it if you can cancel this one, because if we substitute 1 here, we come up with 0. You are not allowed to substitute 1 here, because 1 minus 1 is 0. So in order to solve this one, again, we have to use our ability of factoring. So recall all those factoring trinomial, factoring difference of two squares. Okay, we have the common factor, okay, and so on. or you can use the synthetic division. There are many kinds in order to reduce the fraction. So you have to take note that we need to factor the numerator and denominator so that there be something that we can cancel. So in this case, again, this is quadratic trinomial. So it has two binomials. Okay? So the binomials are, we have the x minus 1 times 2x plus 1. So you have to recall again your ability in factoring. So if we factor the 2x squared plus x minus 3, it will result x minus 1 plus 2x plus times 2x plus 3. So therefore, look at this one. You can cancel x minus 1. Okay? So therefore, what we have now is, so therefore this can be cancelled, eliminated. So we can reduce the function into 2x plus 3. In other words, the function of 2x squared plus x minus 3 over x minus 1 is the same as 2x plus 3. So in this case, we can now evaluate this x. Take note, we have this limit. So it is not necessary that if we replace x with 1, it is not necessary that we use 1. It is the limit of that function as x approaches 1. So therefore, we can substitute here just like evaluating function. So remove the word limit, then we have the 2 times 1 plus 3. But the image of 1 here is not necessarily equal to 1. Remember that. We use the sign of equality. Okay, we are allowed to use the sign of equality because we have this word limit. So if we evaluate this one, you can now remove the word limit, then use this as our basic evaluating the function. So therefore, this will becomes 2 times 1 plus 3. The answer is 5. That's it. So the number approaches 5. So the limit of the function, 2x squared plus x minus 3 over x minus 1 as x approaches 1 is 5. This is the answer to the problem in mathematical solutions. Okay? Do not use table for your solution. We used table in our previous slide just to explain the meaning of the limits of the function. So in solving problems about limits, we have to use this process. Okay? So now what will happen before we proceed to the theorems of limits? Let's have another example. So suppose I have another value of function. So the function is 1 over x, and we are about to evaluate the limit of this function 1 over x as x approaches 0. Now take note that we cannot substitute 0 here, because if you have 0, it will provide an infinite number. So never x equal to 0. So what will be the response of the function if we let x approaches to 0? If we let this x be approaches 0, what will be the response of the function? Okay, let's do the same process. We have the table from the left side, and we have to use the table from the right side, evaluating the numbers closest to 0. So we have, let us say, negative. This is our delta. Okay, this is the delta. So this is negative 2. Then we have the evaluate here. If when x is equal to negative 2, the response is negative 0.5. Okay, so we have this value below. This is third quadrant. Then when x is equal to, let us say, 2, then the response is 5. So therefore, above this line, it should be in the first quadrant. This is in the third quadrant, very close to 1. Now move towards 0, let us say negative 1, the response is 1. So therefore, we have this value. Okay, so we have this value. Then when x is equal to 1, increasing. Take note, this is increasing negatively. Okay, the function from negative 5.5 increases by number to 1 negatively, and this one also increases its number positively from 0.5 to 5. So if we continue moving x towards 0, what will happen? Let us say 0.5 here. This is the 0.5. Okay, then we have the response is 2. Okay, Then if you increase again in the right side, then we have the value. By the way, y is drawn not to scale, so we are only concerned with, do not matter with the calibrations of our graph. So the important is x, the function in the right side is increasing its number, while in the right side also increasing positively, the left increasing negatively. So look at the trend, it is keep on increasing. Look at the response. If you substitute it, then in the left side it is moving in this direction, and in the right side is the trend is moving towards this axis. Actually, it won't touch this line at 0 because you are not allowed to substitute x. So the response must be asymptotic to this axis. So it will move towards very close to this axis, but it won't touch this line. So therefore, again, continue. If you increase the number in the left side approaches 0, look at the response. And while at the right side, the response also keep on increasing towards the positive x. Okay? So, that's it. So therefore, look at the number. Do they have a common point in our previous, in our previous problem, it coincides at 5. But this case, it is inversely proportional. Once you approach, let x be approaches 0 from left, it will move negatively, a big number, while the opposite side, from the right, approaches 0, it will move positive in a bigger number. So, therefore, look at, this is the possible graph, or this is the graph of the 1 over x. This is, we call this as curve sketching using this process. Okay, then, so therefore, look at the result. They are not equal. As you move towards closer to 0, then this difference will become bigger and bigger. Okay? So therefore, we can say is the limit, therefore the limit of the function 1 over x does not exist at x is equal to 0. Okay? So the limit of the function 1 over x as x approaches 0 does not exist. Unlike in our previous, so therefore, the limit of the function can be, will exist, or maybe does not exist. So, depending on the, upon the evaluation process. So, you have to say something. Okay? So, we call this as the two-sided limits from left and from the right. So, in the two-sided limit, the limit does not exist. But if we studied in a one-sided, because the left hand is the one-sided and the right hand is also one-sided, then the one-sided limit exists in this part. But the two-sided limit, because we are evaluating the function, the limit of the function, as x approaches to that number, then we can say the limit does not exist. Okay, now, to evaluate the limit of the function, we need theorems. Okay? Theorems, these theorems are used in order to evaluate mathematically the limits. We will not use tables all the time. Okay? So in order to do it, you have to memorize the theorems. Not necessarily memorize, you have to familiarize and apply it, because once you applied, then it will automatically comes out during the process. So theorem, limit theorem number 1. We call this as the limit of a linear function. So this is the same in our previous or number 1 example, evaluating limit using table. We come up with a linear. Okay, so linear, if we have this kind of linear, remember linear is mx plus a. So we have the mx plus b. Okay, this is linear, so slope and the y-intercept. So if you evaluate a linear function, remember linear function is a function that has a degree of 1. Okay? So, this is linear. So, if you evaluate the limit, you can substitute a here. That's it. So, do not substitute here because we have no value of x. So, remember that a is intended only for x. So, therefore, since we have only x here, adjacent to m, The answer is MA plus B. This is it. That's why in our previous, we have 3 times 2. Okay? Ano? 2 times 1 plus 3. The result is 5. So in this case, M times A plus 5. So this is the answer. For example, if we have the 4x, the limit of the function 4x minus 5 as x approaches 10, this is linear. Okay? So if this is linear, then again, substitute this x here, then that's it. Evaluate. This is the same as we evaluate the function. Pero remember, this process now is different from evaluating the function because we are evaluating the limit of that function. So the word limit signifies that we are not using exactly 10 here. We use 10 approximately equal to 10. So meaning, this can be 9.9999 or it can be 10.0001 something. So it comes up with this negative 46. Actually, this is not exactly 4.6. 446, negative 46. It is very close to this number. But because we have the word limit, then we are not allowed to use the sign of equality. Okay, theorem number 2, limit of a constant. So what will happen if our function is a constant c? So the limit of constant c as x approaches a is the same as c. Okay, so therefore nothing will change for the limit of a constant. So why? Because there's no x here. So therefore leave it as is. So therefore in this theorem number 1, actually this one is a constant, so we leave this b equal to b. But this one, because we're the variable, then we have that result, m times a. So very obvious, the limit of a constant is a constant. So for example, evaluate the limit of 30 as x approaches 10. The answer is 30. Suppose we have the cosine of 60. Evaluate the limit of the function as x approaches 10. The answer is cosine of 60 or 1/2. Okay? Then, another theorem is the theorem number 3, the limit of identity. Identity means 1. This is the same as the domain. So, x is the function. This is y is equal to x. And we evaluate the limit of the function x as x approaches a. The answer is a. So, the identity, actually, if you evaluate that, is this the same as the a. So, for example, what is the limit of x, the function x, as x approaches negative 7? The answer is negative 7. Okay? So, next is the theorem number 4. The limit of sum and difference of function. Okay, what will happen? If your function is composed of sum or difference of another functions. Okay? So therefore, all you need to do is to evaluate each function, the limit of this function as x approaches a of this function x, then plus or minus the limit, okay, so this, therefore, just like removing or grouping symbol, but this is actually following the sum rule or difference function. So all you need to do is to evaluate this function as x approaches a. Then next, evaluate this function as x approaches a. As long as there is x, remember this is gx and this is fx. So we expect that there are constant of this value. So all you need to do is to supply. Then continue. So therefore, this is L is the result of the function of x. And we let the function of gx be equal to m. So all you need to do is to sum up. If there are other functions here, just add, subtract, add, subtract. Okay? This is add, subtract, add, subtract. So that's it. So suppose we have this one. The function is 4x squared plus 3x minus 8. And this is forming sum and difference. Okay? So all you need to do is to individually evaluate the function. This is fx, this is gx, another function. So its term or its term, that function can be, we can use the limit, the same limit. So the limit of this 2x squared as x approaches 10 plus the limit of 3x, this is 3x, as x approaches 10. Then finally, we have minus because it's minus, the limit of the function 8 as x approaches 10. And after that, use the previous okay, theorem. So we can easily substitute it here. 10. So this will becomes, when you evaluate this one, this will be x replaced with 10 square it in times 4. So take note that once you insert this x here, remove the word limit. Okay, we remove the word limit, but this is still in our mind that this 10 is not exactly equal to 10, very close to 10. So we are now allowed to use an inequality because we have this word limit. So evaluate using algebra, okay, so calculator, then we have this answer. Now theorem number 5, the limit of the product. Now what will happen if the function is forming product? Suppose we have L times M. If x times gx. So this is plus or minus, this is multiplication. So what will be the result? Okay, the same. Evaluate this function, call it as L. Evaluate this function gx, call it as M, then multiply. Okay, this one we add, we subtract. We add, we subtract. This one we multiply. So nothing difficult here. So suppose we have this x minus 4 times x squared plus 3x. Then evaluate the limit as x approaches negative 2. So all you need to do is to substitute here, then substitute it here, substitute it here, then multiply the result. Okay, so we have this one. Evaluate the function. Okay, we have this multiplication sign, and we have this result. So evaluate this, the result is L. Okay, or we have these two results. So this one is actually evaluating. Okay, you can use the sum rule again because this is forming sum. Then do it the same. Okay. By the way, this step is using the theorem. But take note that if you analyze this result, okay, substitute it here, evaluate, okay, it is just the same as we look at this one. If I go directly without following the steps here, I will evaluate this function, substitute this x with negative 2, this is it, and minus 4. Then this next factor also, put it here, so negative 2 squared, this is 1, this is the one. Then plus 3 times negative 2. Okay? So you can escape this processed one. This is only for the sake of calculation discussion that we explain using the theorem, that we are allowed to use that. So for your solution, you can go directly to this process and use your calculator to evaluate, and we have this value 12. Remember, this is not exactly 12. Not necessarily be equal to 12. Why? Because this is not necessarily equal to 2. So you notice that the limits exist. For example, this one exists as 422, and this limit exists at 12. So all our examples exist at a certain number, which means that the left hand coincide with the right hand limits. Okay, number 6, we have the power. So the same. If we have the function raised to a number n, now all you need to do, take note, this is function raised to n. You can penetrate the limit inside. Do it this way. So you can penetrate. Remember, this is an operator, so no need to square. You cannot apply the log exponent here because this is not a number. This is an operator. So therefore, using the theorem, you are allowed to absorb the limit operator inside the grouping symbol. And this one, we can now easily find the function of the limit of the function as L and raised to n. Okay, so that's it. Because it is now become simple if we let the operator be inside the grouping symbol, so that we can use our previous theorem. Then after that, take the power of n. Okay, for example, okay, this one, remember that we are allowed to penetrate inside, so you can do this way. So I inserted the operator inside the grouping symbol, so there's no such difference between the two. They are equal. Why? Because this is not a number, this is an operator. Okay. Now, we can use the sum rule individually. So therefore, we have that. Okay. Then, so therefore, we are now ready to evaluate this one and this one. So, we come up with 2 square plus 3 times 2, then quantity, or raised to 3. Okay? Again, similarly, you can skip this process because when you look at this result, it is simply as we inserted 2 here, becomes 2 raised to 2, and 3x will be inserted by 2. So therefore, again, skip this process, go directly with this result. That's it. As easy as that. So we present this for the sake of discussion and following the rules of that, in order to show you that this is why we arrive this result, because we follow the theorems of differentiations. Okay? Now, if the problem says that use the theorem to evaluate step by step, then you have to go with the process, because it might be you might be given points in doing that process, so you have to practice yourself using the theorems. But for the quick result, then go directly. Okay, so the answer is 10 cubed, or it is 1,000. Now, number 7, the nth, meaning if we have the radical expression, involve radical expression, so the nth is actually the index of the radical, the n. Okay, so therefore in this case, all you need to do, nothing to worry, you have to go, you can insert inside, then evaluate, then we have the nth of L. That's it. So for example, you have this one. So all you need to do is to insert the, remember, we are free to, the limits is free to move inside anywhere, because this is just an operator. So operator, limit operator, see, we have the actually allowed, limit is allowed to penetrate inside. So do it. Then the purpose of doing that is we can see the simplicity of the process. So therefore this will becomes what? 2 square, and we have insert here 2x, 3x, 3 times 2. So therefore we have 4 plus 6 equals 4th root of 10. Okay? Again, you can skip this one, then go directly by inserting x here. That's it. Then we have this result. Now, the last theorem, number 8, is the trigonometric functions. Okay, we have the squeeze theorem. So this is a very special kind of situations, and this is usually applied for the simplifying the function. If we have this, which means that if we encounter this kind of problem, the limit of the sin t, by the way, this is sin t, so this must be t, sorry, so this must be as t, because it is not only x, it is not necessary x. So in this case, we have the limit of sin t, t means the domain or the angle, then divide by t. This is exactly equal to this number, the denominator. Then you can, and this is sine, so see it as 1. So therefore, if you encounter this one, make it 1. So the expression now becomes simple. Then if we have 1 minus cosine the angle, and we t, and all over t including 1, and t approaches 0, then this will become 0. So these are special theorems, and this is very useful, especially if we are deriving the derivative of cosine, derivative of sines, and so on. And there are other applications to the squeeze theorem, usually derivation process. Okay, so we will reserve this idea. Do not forget this formula. Okay, now the one-sided limits. Okay, the one-sided limit is, take note, this is focus on the point. So the theorem says that the limit of a function as x approaches a is equal to L. exist, okay, unequal to L, provided if and only if that the limit of the function as x approaches a, and we have the just like exponent, this is negative. This signifies the limit, left-handed limit. The exponent negative signifies the left-handed. You remember in our previous discussion, we have the left side and we have the right side. So the negative means the left side, left-handed limit, while the limit of the function as x approaches a positive is the right hand limit. So according to this theorem, the limit L, the limit of the function as x approaches a is L only provided that the left-handed limit and the right-handed limit exist both and equal to L. So therefore, just like what we did in our previous example, that the left hand arrive at 5 and the right hand arrive at 5. So they have the same value. So therefore, we can say exist. Okay? So therefore, if we, in order to evaluate the two-sided limits, whether exist or does not exist, then we have to use the one-sided limits. So we have the left hand, we have the right hand. Actually, we do it in our previous. Working with left hand or working right hand is actually the one-sided limit. If we do it simultaneously, it is a two-sided limit. So the two-sided limits will exist. This one, the limit of the function as x approaches a, this is two-sided limit, will exist only if we use the principle of the one-sided limit, the left-hand limit and the right-hand limit. Take note, the exponent, just like exponent, a raised to negative means left hand, and the a raised to positive, means the right-hand limit. Okay, now we are given this problem. Let f now defined by, this is the piecewise function. So we have the function of x. So there are three functions of function of x. We have the x plus 5, and this is in the condition of all x's are less than negative 3. So numbers that before 3, negative 3, the function is x plus 5. But between negative 3 and positive x's, the function is square root of 9 minus x squared. And more than 3, look this one. For more than 3, meaning x is greater than 3. So therefore, the equation of the function now becomes 3x. We call this as a piecewise function. There are 3 different functions for different conditions of exist. So therefore, we have different graphs also because we have different functions. So what do you think? What is the form of the graph on this one? Let us see the graph. Look at this one. Negative 3. So we have this negative 3. And this is, remember, this is linear. So the line is, the slope of the line is open to the right. So, okay, the slope is 1. So therefore, it should be 90 degrees. So this is 1 rise, run. So therefore, this is approximately the graph of the, and we have the arrow here. The arrow signifies infinite, towards negative infinite. But take note, this is 3 is not included, so we use the open circle here. So 3 is not included, negative 3 is not included. Okay, now this one, square root of 9 minus x squared, between negative 3 and 3. So we have this one. So take note, this is a semicircle. Okay, when you grab this one, if you substitute values here between 3 and negative 3 here, substitute here between 3 and negative 3. Take note that negative 3 is included because we have less than or equal to, or less, okay, or equal to means 3 is included, positive 3 and negative 3 are included. So we use the solid arrow, solid circle, and this is open circle, signifies not included. So this is the graph of the square root of 9 minus x squared. Then when x greater than x, we come up with x minus 3. This is, remember, the slope is negative. So it should be open to the left. So it should be this one. Okay? So Again, 3 is not included in this function. But remember, it is included in the square root of 9 minus x squared. So then, therefore, that's it. Okay? So, this is the graph of this piecewise function. So, let us now evaluate if this exists. Remember, the boundaries are negative 3 and positive 3. So, we will analyze if negative 3 exists. Look at the graph. 3 and negative 3. Negative 3 and positive 3. So, let's have analyze the limit at x approaches 5. This one. Okay? So, we will use this equation because this is in the condition of the left hand of negative 3. So, the left hand is this one. This equation. So, we have x plus 5. So, is this exists? The answer is yes. Because this is substituted here. Use the same theorem. Okay? Ignore this negative because this negative means exponent means left hand. So, we do it already. So, negative 3 plus 5 is 2. That's it. So, it exists at 2. So, the left hand limit is exists at 2. Now, next is evaluate the right hand. The right hand is this one. The right hand of negative 3 is using this function. So, is it exists at negative 3? The answer is yes. It's 0. So, the left-handed exists. Both of them exist. Now, the question is the function L, a function fx exists at negative 3? The answer is no. It does not exist. Why? Although the left hand exists, but it is in 2. The right hand exists, but it is in 0. They are not equal because the requirement, both of them have the same value. So therefore, we can say it that the function x does not exist at negative 3. Because, why? Because the left hand is not equal to the right hand. Okay? So, these are your remarks. The function f does not exist at negative 3. So, the limit of x, negative 3 does not exist. Now, we still have to investigate the limit of the function as x approaches 3 because these are the boundary conditions. These are the critical points. It is where that the two functions coincide or analyze. So, first, again, we have to use the left-handed. So, take note, this is negative left-handed. So, in this case, at 3, remember, we are now on 3, positive 3. Previously, negative 3. This point, we are now on this point. So, the left hand now is the square root of 9, while the right hand is the x minus 3 minus x. So, therefore, it exists as 0. When you substitute it here, the result is 0. Exists. The left hand, look at the left hand. If you substitute it here 0, the answer is 0. Okay? Now, both of them, the left hand and the right, have the same value. So, therefore, we can say that the function exists at positive 3. That's it. This is how to evaluate the function. If it is exists or does not exist. Use the one-sided limit, the left hand and the right hand. Then compare the two. If they're equal, that's it. That's the result. Okay? Now, we have the infinite limits. What is the meaning of infinite limits? The infinite limits means if you evaluate the function, evaluate the limit of the function using your A, the result is infinite number. So we call that as the infinite limits. Means L is an infinite number. Sometimes we can encounter that value. So we call that as the vertical asymptote. Vertical asymptote means it will move, the result will move towards the y-axis, the vertical axis. So it is a vertical asymptote. If your limit approaches, or if the limit of the function as x approaches a is infinite, so we call it as an infinite limits. So the theorem says that the limit of the function is infinity if the value of the function increases without bound. So which means it continuously increasing or decreasing its number, positive and negative. As x approaches a number a, so therefore we have this as a symbol. So, if you substitute x here, the result is infinite. Okay, so positive without bound. And the limit of the function infinity, if the value of the function decreases without bound, so decreases without bound means it is negative infinite. So we have this value. So these are the two results of the infinite limits. It's either positive infinite or negative infinite. Okay, example, determine the limit of the function. The function is 1 over x minus 3 squared. Evaluate this as x approaches 3. So, take note that when you substitute it here, when you substitute 3, the result is 0. And we cannot reduce this one. Okay? We cannot reduce this one because it is already simplified. Unlike in our previous that we can do something because we can factor it out, then analyze if there's something that can be cancelled. Now, if we have this, we have numbers that cannot be reduced or cannot be expand and cancel something, because the reason why this will become 0 because of x minus 3. So therefore, all the time this will be 0. So in that case, this is actually an infinite limits. So the question now is this positive or negative? Okay? So therefore the solution now provides the infinite number. Okay. So we call this as an infinite limit. But this, take note, there is a positive and there is a negative. In this case, remember this is, we substituted here 3. But remember, we have the left hand and we have the right hand limit. Okay? So we can use the left hand limit, then it will respond. So therefore this is a positive or a negative result. Sorry. This is positive. It can be a positive and it can be a negative if we use the left hand and right hand limit. Okay? So we have this example. Find the vertical asymptote. So this now obvious that the answer is vertical asymptote, means the answer is always infinite. So find the vertical asymptote of the graph, the function f defined by this function. So 3 over x minus 3. So therefore, we have to use the left-handed. So what is the left hand of 3? 2.999. Okay, so substitute 2.99 here. So therefore, this is less than compared to 3. So the answer is a negative infinite. Okay, again, why is it negative? Because this number is less than 3. So less than 3 and this is 3. So it dominates the negative. So therefore, we have that one. So the answer is, now for right hand of 3 is 3 point something. So this is now greater than 3. But remember, this is 0. So it will arrive the same infinite, but this is positive. So these are the vertical asymptote. This is decreasing without bound, and this is increasing without bound. That's it. That's how we answer infinite. You can encounter problem infinite if you cannot reduce it and cancel something. So in this case, this is just like a dead end. So therefore, we have now the infinite number. Okay, so if we have the vertical asymptote, we have the horizontal asymptote. The vertical asymptote is asymptotic to the y-axis, while the horizontal asymptote is in the horizontal axis along x. So therefore, our limits now is a number, but our a is an infinite number. So in this case, look at this one. The limit of the function x, function of x, as x approaches infinite. This is now, so if your a is infinite, it is horizontal asymptote. So asymptotic to the x-axis, and the number exists at L. So for example, we have this function x3 x squared equal to the limit as x approaches infinite. Then this is a big number. Okay, so therefore this is 0. So if you increase what is the meaning of this? If you increase the value of x asymptotic to the x-axis, then the response becomes 0. So y becomes 0 if you increase the value of. So that's the meaning of that. So for example, this one. Suppose I have 1 plus 1 half raised to 2. Yeah, evaluate the limit as x approaches infinite. So this is an infinite number. So remember, this is 1 half. Okay? If you raise a number increasing to that number with less than 1, this will become 0. Okay, you can try it using calculator. If you increase this to infinite number, this will become approaches 0. So therefore, in that case, the answer is 1. Okay, this one, substitute it here. 1. What will happen? Now remember that this is a large number and this is a large number. Okay, now all you need to do is to factor, then take, look at this one, this will be cancelled and the answer is 3. So therefore, if x approaches infinite, it has a constant value of 3. So do not attempt to use your calculator to substitute here because you cannot solve using calculator. Instead, you have to factor so that you can cancel. Okay? So this one, exponential problem. If we have this exponent x here, and if you increase this one, okay? Now take note that the negative exponent will approach this what? This is 0. Okay? Take note, this is the same as 3 over, this will become positive. So if this is a large number, very large number, because this is infinite, so this will become 3 over a large number, which is what? This is approaches 0, actually. So as x approaches 0, then we have this, approach infinite, we have the 0 answer. Okay, then what's the purpose of having the vertical and horizontal asymptote? The importance of the horizontal and vertical is to sketch the graph of the function, and this is using the limit principle. So we will use the vertical asymptote, horizontal asymptote, then we can evaluate in between we can evaluate the limit of the function, so using the previous. So actually the purpose of the limit is to sketch the graph and to evaluate the limits also. So then let us sketch this function. So in order to provide a sketch of the function, x minus 2 over x plus 3 using limit principle. Now all you need to do is to have the graph. Okay, this is our graph. Then first is to find the horizontal asymptote. Take note, horizontal asymptote is asymptotic to x. So all you need to do is to evaluate first in the negative infinite. So what will happen if you substitute here? Okay, the result is, okay, this is a large number. Okay, so this is negative infinite and negative infinite. This is approximately equal to what? Equal to 1. Because this is almost the same. This is a very small number compared to this number. So it will dominate with infinite number. So just like Carabao with insect on his skin, we cannot see the small particle on a Carabao because of its large size. Okay, so therefore what will happen is if you add a negative 2, it doesn't affect the result. So this will becomes negative infinite, and this is also negative infinite. So therefore this is 1, because negative is 1. So therefore, if you construct a drawing, if you increase this infinitely, then the response y is 1. Okay? Now, in what will happen if we reverse the x approaches infinite of this function? So do it. This is positive infinite. Again, this will not affect the calculations, and this is positive. The answer is 1. Okay? So therefore, if we increase the answer towards the positive, the answer is 1 positively. Okay? Now, what will happen in between? So in between is we will use the vertical asymptote. Now take note that the value here should not be equal to 3. Positive 3, negative 3. Because if you have negative 3, the answer is 0. So that's the time that it is undefined, but it is a vertical asymptote. So therefore, in the vertical asymptote, x should not be equal to negative 3. So we have this restriction here, line. It should not be equal to negative 3. The graph will not pass through this point. Instead, it will move asymptotically. Okay? Means it will be closer to this axis only. So what will happen if we use the left hand limit at negative 3? So at the left hand of negative 3, again, this is 0. So the answer is now infinite. Okay? Infinite number. So this is negative 3 point something, because the left hand of negative 3 is 3 point something, 001. This is now greater. Remember, the same sign, the value, but negative sign. This is greater compared to 3. So therefore, this positive, negative over negative. So negative over negative is positive but infinite. So therefore, the graph here is moving upward. As you move closer to negative 3 from left hand, the response of the function is asymptotic to the positive y-axis. Now what about this one? In the right hand side. So in the right hand side, you have to use the positive, which means that it is the right hand of the negative 3. Okay? Then the response is what? If you substitute it mathematically, negative, negative, still negative, but this one, look at this one. This is less than 3. So therefore, this will be positive. So negative divided positive, the answer is negative infinite. Take note, in the vertical asymptote, answer is always infinite, but it depends upon the sign. It can be positive, increasing without bound, or decreasing without bound. So therefore, in this case, this is decreasing without bound. So remember that it won't cross the line of negative 3 because you are not allowed to use negative 3. So instead, they will move in this direction. So therefore, this is the graph of this function. Okay? That's it. This is the purpose of having the evaluating the limits. We can sketch the graph of this function. This is transcendental function, remember. But we are able to see the graph using the vertical and horizontal asymptote. Okay? So, just go back to this video if there are something that, or you can ask me about, or questions about your problem here. Okay, now finally is we have the continuity, the function. The continuity of the function is actually investigating if there's a continuous point between the two, from the left hand and the right hand. So there must be an investigation whether it is continuous or not non-continuous. So let x be represent the function with a domain that includes the point A. So we have point A, x A. Then the function is continuous. Okay, at that A is continuous if and only if the limit of the function as x approaches A is equal to the function of A. Which means that, remember, limit is evaluating the function but not necessarily equal to that number. And this one, the function of A is exactly A. So if you substitute that value exactly A, you are evaluating the function. You're not evaluating the limits. So if these two conditions satisfies, then we can say that the function is continuous. Okay? So the limit of the function exists if and only if the left hand, okay, there are two investigations of this. Remember, this is two-sided. So you have to use the one-sided limits, the left hand and right hand limit. This should be the same. So if they have the same value, then this is exist. If this is not exist, then it is not continuous. Okay? Then for the second condition, this is the first condition. The second condition, the function A also exists. Okay? So if they are exist, then condition 3, the limit of the function should be equal to the function of A. These are the investigations in order to say that it is continuous or discontinuous. Now, why is it that we studied continuity of the function? Okay, we need to study this one because as we go on in our topic in calculus, in differential or integral, see to it that you know that in that domain, make sure that the domain is continuous. Because if it is discontinuous, you cannot differentiate, you cannot integrate because there is a jumping point. it should have the point that represent to that, and it should be connected, because if they are unconnected, we have the jumping point. Okay, then it is not non-differentiable. If non-differentiable, not integrable. So the first investigation to integrate, you should know if it is continuous or discontinuous. If it is discontinuous, do not differentiate, do not integrate. If it is continuous, then you can do it. Okay? So, for example, we have this a function of 1 over x squared. Is it continuous to 0? Or is it continuous to 1? How to investigate this one? So the answer is, first is, okay, a is equal to 0. This is for the first question. Then, evaluate first condition number 1. This should be exist. Okay? So if you evaluate this one, the left hand of x0 is, remember, negative number, is infinite. And the right hand is infinite. So therefore, okay, we have this number. But remember, this does not exist because this is not an exact number. Although they have the same answer, but this is infinite number, so does not exist. So if this does not exist, even though if this is exist, the item number 2, still you cannot say that it is continuous. So both of them does not exist. So condition number 3, they are not equal, so therefore the function does not exist at 0. Okay? Now what about for a is equal to 1? For a is equal to 1, the limit of the function at x is equal to 1, is it exists, or is it continuous or discontinuous? So to investigate, we have to use the 3 conditions. The first condition, the left hand, evaluate, then we have the 1 value. Okay? The right hand is also 1. Okay? Any number closer to 1, the result is 1. Okay? This, which means that we can say that the limit of the function at x is equal to, sorry, this is 1. This should be 1. This should be 1. 1, this should be 1. Sorry, I cannot change this to 1. Change this to 1. So, exist. Now, another condition number 2, evaluate the function without limits. No? Substitute this with 1. So, the answer is 1. So, in that case, your limit of the function is 1, and the function of a is also 1. So, therefore, they are equal. So, we can say that the function of 1 over x squared is continuous at x is equal to 1. So, therefore, the function is differentiable at 1 but not differentiable at 0 or integrable later on. That's it. So, that's it. Next topic is already talking about the differential calculus. See you.